Hello everyone. In this video, we're going to be solving a problem from a book in Russian that contains 113 beautiful problems. So we have e to the power x minus 1 equals ln of x plus 1, and we're supposed to solve for x. So this is a non-standard equation, so we're going to be using a different method because we have an exponential function on the left-hand side and the logarithmic function, which is base e, on the right-hand side. Okay, so let's go ahead and take a look. I'm going to go ahead and call this y. So from here we get the following equations. First of all, the first one gives us e to the power x minus 1 equals y. And let's go ahead and work on the second equation a little bit. If you raise e to the power both sides, you get x plus 1 is equal to e to the power y. And from here we can basically say that x can be written as e to the power y minus 1, or I can write this as e to the power y minus 1 equals x. So this equation basically gives us a system of equations which we can solve. So in order to solve this system of equations, I'm going to do the following. And after this method, I'm also going to be presenting an alternative way to approach this problem. So now I'm going to subtract both equations. So e to the power x minus 1 minus e to the power y minus 1 equals y minus x. The negative ones cancel out, leaving us with e to the power x minus e to the power y equals y minus x. Now I'd like to put the x's on one side and y's on the other side, so we can write it as e to the power x plus x equals e to the power y plus y. Great. Now I'm going to consider the following function, and my function is going to be f of t equals e to the power t plus t. The reason why I use a different variable is because I don't want you to get confused, because we have two variables here, x and y, and I'm basically evaluating my function f at 2 points. One is going to be t equals x, and the other one is going to be at t equals y. All right. Now what happens if we do that? We basically get the equation f of y equals f of x. Now, what does that imply? Well, first of all, let's take a look at our function here, which is given by this equation, and let's see if that's going to be a one-to-one function or not. So I'm going to differentiate this function, and when I differentiate it, it's going to be e to the power t plus 1, because the derivative of e to the power t is itself, and the derivative of t with respect to t is 1. Now this shows always a positive value, because e to the power t is always positive for all values of t in the domain. So our function has a positive derivative, which means that f of t is always increasing. Now this is important because we have a function that's always increasing, and f is also a continuous function because e to the power t is continuous, t is continuous, and their sum is also going to be continuous. So you're basically talking about a function that is always increasing, whatever that looks like, and it's continuous. So there are no holes or gaps or jumps or anything like that. And we're basically looking at the function at two different values and they're equal. So this implies f of y equals f of x implies y equals x. All right, that's the conclusion we get from here. So going back to our equation, we can safely say that e to the power x minus 1 equals y, or we can write it as e to the power x minus 1 equals x. Okay, great. Now, we're going to be solving this equation now. How do you solve this equation? Well, you can kind of guess and check, and you could do that at the beginning as well, but I'm just going to want to look at this equation a little bit. So if you replace, for example, x with 0, you're going to notice that x equals 0 is a solution. But the million-dollar question is there another solution to this equation? And that's what we're going to be looking at. Okay, so now let's take a look at the following function. How about we consider the function y, maybe let's just use a g here. G of x equals e to the power x minus 1 minus x. Okay, now what type of function is this? Well, we know that g of 0 is equal to 0. So we have one x-intercept. And then let's go ahead and differentiate this function as well. It's going to give us e to the power x minus 1. And now, if you look at e to the power x minus 1 and set it equal to 0, from here you get e to the power x equals 1 and x equals 0. So we do have a critical point at x equals 0, let's go ahead and find out what that looks like by looking at the table for the derivative of g of x. So the derivative has a root at 0, and we know that this expression, the derivative, is going to be positive if x is greater than 0, because e to the power x is going to be greater than 1 in that case, and it's going to be negative. So this means that g is going to be a decreasing function if x is less than 0, and an increasing function if x is greater than 0, which means that we have a minimum at x equals 0. And another thing, this means that we have a minimum at 0, and g of 0 is also 0. So our function is going to touch the origin at 0, 0, and then otherwise it's just going to be increasing and decreasing, which pretty much means that it is only going to have one x-intercept, which means this equation has only one solution, and that is 0, which again verifies that our original problem has one solution at x equals 0. Okay, let's take a look at the original problem, and it is e to the power x minus 1 equals ln x plus 1. So if you replace x with 0 here, you're going to notice that e to the power 0 minus 1 equals ln 0 plus 1 gives us 1 minus 1, which is 0, equals ln 1, which is 0. So we got a solution, but that is the only solution that works. Okay, let's take a look at another perspective, which involves the graph of these two functions. Now, if you look at the graph of these functions, by the way, I'm using desmos.com to make these graphs, and I'm not sponsored by them in this video. But anyways, I just wanted to mention it because a lot of people are asking, how do you make these graphs? So you have a graph of these two functions, and what do you notice about this? These functions are inverses of each other. Obviously, if two functions are inverses, they're going to be symmetrical with respect to the diagonal y equals x. So they're only going to be intersecting at y equals x, and that shows you that they're going to have a single solution, and that is going to be x equals 0. All right, so our equation has only one solution, and that is x equals 0. Great. This brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.